As we've seen, an equation like this can't simply be integrated term by term, because our integral would be with respect to t. In order to get x from x prime, we'd have to integrate this x prime with respect to t, meaning that our integral of x would have to be with respect to t, not with respect to x. We could integrate the 2t with respect to t, but we could not integrate an unknown function x with respect to t. So we're going to learn to integrate this function fairly soon, or we're going to learn to solve this differential equation, this type of differential equation, fairly soon, but right now let's regard this as an unsolvable differential equation. And most differential equations that you can write down are in fact unsolvable. We're going to look at the geometry of this situation, which is simply how do the solution curves behave in an x versus t plane. If we start from the point of t equals 0.8, x equals 0.4, where will our solution curve lead us? Well, we can make a pretty good guess as to where that will be. So if we start at the point 0.8, 0.4, what we're saying is that our solution function x, now our solution function is going to be x of t, and we're saying that x of 0.8 has to equal 0.4. Now remember the form of our solution. X of t equals, well, ignore that. Okay, x of 0.8 equals 0.4. Now what can we determine from the differential equation? Well, we can determine something rather important. X prime is just the derivative of the x versus t function, which means that the value of x prime is going to be the slope. So that this says that the slope at the point 0.8, 0.4 will be x prime of t equals, x is equal to 0.4, so that's 3 times 0.4 minus 2 times t, which is 2 times 0.8. That's 1.2 minus 1.6, or negative 0.4. So what this is telling us, what this function tells us about the solution at this, in the neighborhood of this point, is that the slope is negative 0.4. Now we'll see where that leads us in a minute.